Okay, right. So let's try to understand a bit of implicit differentiation of implicit functions, if not implicit expressions, right? Okay, so there are like 6 questions. I'm going to explain to you how to differentiate each one. Okay, so let's start with the first one. So it says x squared plus y cubed equals 2x. So let's do it then. So we're trying to basically, in differentiation, what we're trying to find here is dy dx. dy dx in terms of normally x and y. Okay? So the reason it says implicit, because when you get the answer, usually the dy dx consists of x and y both, the expressions. You will see in a minute what I mean by that. So let's try to differentiate that. Question number 1, it says x squared plus y cubed equals 2x. Now we're trying to differentiate each term here, each of these terms. If you differentiate this, you're going to get 2x. See, differential of x squared is 2x, because you're differentiating in terms of x, all of them. Okay, so step 1, differentiating in terms of x, all of them. So that's going to get 2x. Now we try to differentiate this one in terms of x. So for the time being, let me write it like this if you want. Just break it down a bit in a minute. Differentiating that one going to give us 2. Okay. Now this one I can rewrite if I want like this, 2x plus. Now y cubed can be differentiated in terms of x. However, the answer is slightly different here. Think y cubed as a function of x. If it's a function of x, obviously it is a function of x. It's going to be 3y squared. For an example, let's say it's x cubed, then it will be 3x squared. In this case, it will be 3y squared. However, because this is implicit, because the x is hidden inside, so we have to differentiate y again by itself, called dy dx. You see, that's our idea. So basically what we did there is this. We took this dy d cube dx. So what we really did here was this. dy cube dy times dy dx. You see? That's exactly what we did. Basically it's chain rule, isn't it? See, can you see they're cancelling out here? You see? So what we're going to get here, 3y squared. 3y squared dy dx. See, that's equal to dy cubed dx. So we can basically write, if it's confusing, you can just write it like this, separate it. They cancel out, you can clearly see that. It's a chain rule basically. Okay, so that is 2. So now we can simplify. So let me just get rid of this bit. Now I can move all these things to the other side. I'm going to get 2 minus 2x equals to 3y squared dy dx. Okay. Now what is required here, dy dx? So I can divide by 3y squared. I'm going to get dy dx equals to 2 minus 2x divided by 3y squared. That's basically the answer. You see, the answer now is in terms of x and y both. So because of this nature, we use this implicit differentiation. Implicit is hidden. Implicit means within. It's not explicit. And explicit ones are pretty simple ones, like y equals x squared plus 1. The answer will be everything in terms of x, but here in terms of x and y both. Okay, it's pretty simple. Let's do some other few questions. Right, question number 2. 3y squared plus x equals 3x squared. we can differentiate each one again. Let's differentiate, that's the function of y, isn't it? So let's leave it like that. Because that's a constant, so I'm going to write it like this. Differentiate of that is 1, differential of that 6x. Now again, this one can be rewritten like this. dy squared dy times dy dx. So again, like we did before, they're cancelling out. Now there's no confusion. Now the differential of y squared in terms of y would be 2y. So 2y times 3 would be 6y. 6y dy dx equals, I can just move this one to the side straight away, 6x minus 1. Okay, so I did two things at once basically. I moved that to the side. So I'm going to get now dy dx equals 6x minus 1 divided by 6y. That's it. Okay. So if you want to find dy dx for an example and x equals 1, y equals 1, we can just sub the values there and find dy dx at any point. Basically you need a coordinate, both coordinates, x and y. Because it's implicit, you need x and y both. If you want to find it, what you call a stationary point, then you can equal this one to 0. Then you're going to get 6x minus 1 equal to 0, which means x equals 6. So when x equals 6, you will find all the stationary points. Okay, like that. You can interpret this one the way you like, depends on the questions. Right. Alright, so let's try question number 3. It's x squared plus 5x minus 8y plus 3y squared equals 0. Differentiate everything in terms of x. You're going to get here 2x, 5 here, 8. Differentiate in terms of x, just dy dx. That's all. Because it's a function of x, but we don't know exactly what it is. Okay? Differentiating that, so we do the same thing what we did before. Just writing it like this, maybe easy for us. Writing as a chain rule. So that's basically 2x plus 5 minus 8 dy dx. So that's basically dy dx, that becomes 2y. 2y times 3, 6y dy dx equals 0. Now what it requires dy dx basically, right? So we can move all the terms to the other side and keep the terms with dy dx in one side. So we're going to write 6y dy dx minus 8 dy dx equals to minus 2x minus 5. Take the common factor dy dx. 6y minus 8 equals minus 2x minus 5. Now we can find dy dx obviously here. I'm just going to write the answer here. Just divide that by that. You can have dy dx equals minus 2x minus 5 divided by 6y minus 8. If you want, you can times everything by minus to make it a bit look better. 2x plus 5 divided by 8 minus 6y. That's dy dx. Okay. That's basically it. It's pretty simple. Differentiate in terms of x, dy dx here, and here, these are the only places you have to be careful. Because you can just chain rule basically to sort it out. Alright, so let's go to the next question. question number 4. It says x squared, slightly different looking question, x squared y plus 3 equals 0. Again, we can differentiate each one. You're going to get 2x as usual, 2x. Now differentiating this one, there are two terms. There are two functions, that and that both. Okay, so you have to be careful here. You have to read product rule here for that. See, there are two functions. So you can use the product rule, the UV rule. That's like U, that's like V. So we have to proceed that way. So what we're going to do there, we can write this U and V basically. It's a product rule. Leave that. Doesn't matter, or doesn't matter. Differentiate that, dy dx. Plus, leave that. Differentiate that, is 2x. Okay, I think it's clear. That's basically that bit. The rest, that's become basically 0. Differential of 3 is a constant, it's become 0. So. Now we can move all the functions to the other side. We can have x squared dy dx equals minus 2yx minus 2x. Then divide everything by x squared now to get dy dx. Dividing by probably everything by x, so minus 2yx minus 2x divided by x squared. We can divide by x, simplify it. You can also take minus 2 out, minus 2, y minus 1 divided by x. Okay, here we assume x is equal to 0. Well, actually it can be, it's fine. So that's basically it. We're dividing. So that's dy dx, that's it. In this question you have to be careful here, realizing it's x and y, u, v. So you have to apply that manner. So differentiate that, and plus the differentiate that basically and keep that, the same, like uv basically. Okay. Here it was left alone, differentiate dy dx, and here that's left alone, differentiate x squared, is 2x, written like that. So the rest is the same. Okay, question number 5. It's an interesting question again. It says x plus y squared equals x minus y plus 1. Okay, so we try to differentiate this. So now this is like as a whole, we can, how do you do this? You can again use chain rule like before. Like, let's say for an example, we had a question, let's say we had a question like this. 3. What you would do, we would differentiate the whole. I mean, as using chain rule, we would write it like this, isn't it? Differential of this can be written like this. Times by the differential of that, which is 4x. Same thing can be done there. Okay? So, so we can do, that can be written like this, 2 to the x plus y, and times by the differential of inside. Now we can differentiate that. If you differentiate this, we can differentiate like this. See? That differential, the whole thing, 2x plus y, 1, and differentiate inside. And differentiate that is 1, differential of y would be dy dx. And differential of 1 would be 0. It's constant. Now here, what are you going to get? We x to x plus y. Differential of x plus y would be, differential of x would be 1, plus that's dy dx. equals 1 minus dy dx. Okay. Now what we require as subject is dy dx, isn't it? So the only way we can do is probably expand it and get all the dy dx to one side. So 2x plus y plus 2x plus y dy dx expansion plus I'm going to bring this one this side, dy dx equals to 1. Because I brought this one here as well. Now I can clearly see here dy dx terms and move this one to the other side. So I'm going to get 1 minus 2 times x plus y equals to that. Okay, so I can take common factor here, same time dy dx is common factor. Yeah, there I'm going to get 1 plus 2 times x plus y. Okay. So the answer can be written now. I'll write the answer basically on the top. Let me write it here. The answer can be written dy dx equals that divided by that, isn't it? So you're going to get 1 minus 2 times x plus y divided by this 1 plus 2 times x plus y. Okay? I think it makes sense, right? Here it's missing a bracket. So that's nothing really new. I mean, well, that was something new same time, but what we did here, basically, we had that x squared here, isn't it? X plus 1 squared, x plus y squared, number 5 you're dealing with. So we had to differentiate this one using chain rule, you know, so that's what we did. Okay, so that's basically it. Now somebody might be wondering, can't we really write this chain rule like we did before? Yes, we can write this as well. For an example, if you want, we can write it like this. For an example, when you're differentiating this, if somebody asks you to differentiate this itself, we can write the chain rule like we did before in the previous examples. We can write it like dx plus y, see, dx plus y squared times dx plus y dx. We're differentiating x plus y squared with x plus y. See the same variable. So the answer here would be 2x plus y. And there, that's fine, differentiating x plus y in terms of x. So what are you going to get? Basically, differentiate x, you're going to get 1. Differentiate y dy dx. That's basically it. Same thing. That's what we plugged into the previous one anyway. If you want, you can check it. Okay. All right. Let's go to the last question then. That's number 6. It says ex y equals xey. Again, it's uv, isn't it? It's just basically there are two functions here. If you note it, there are two functions. That's u, that's v. Again, there are some two functions. So we had to apply product rule. Differentiate ex, you're going to get ex. Leave that is y plus differentiate that dy dx. Leave that ex. And same here. Differentiate that. I'm going to get 1. Leave that plus. Differentiate that ey dy dx. Careful. And leave that. Differentiating ey could be that Or you can say like we did before, differentiating ey means this. We can write differentiating ey can be written dy ey times dy dx, because that is basically equal to ey, and that's dy dx. Alright, so that's basically it. And we can take all the dy dx to one side. You're going to get ex dy dx minus x ey dy dx equals to ey minus exy. Common factor dy dx, take it out. So you're going to get ex minus x ey equals ey minus exy. Okay, so basically we are taking the common factor here, and what left is ex and exey. So now the rest is very simple. We can divide that by that. You're going to get the answer pretty simply. The answer we're going to get here is dy dx equals to ey minus exy divided by ex minus xey. That's it. Okay, pretty simple and straightforward, I guess. Alright, so I think that's I think it's clear. Only these cases are the little when you're differentiating the y in terms of x, that's the one you have to be careful. Alright then, mate. Cheers.